familiar with different types of numbers, for example integers and floating point numbers. We also talked about how to print or display something to the screen, starting with the famous Hello World example. We then talked about variables, and at this point you should know what variables really mean, how to create them, how they can be used, and so on. And lastly, we also discussed how we can read an input from the user. So up until now, we've seen that all the code we've written, the assignments we've done, getting inputs from the user, printing output to the screen, all of these lines of code, all of our commands were executed one after the other in some sort of successive manner, right? And in programming, just like in real life, you would like to have some control over your actions. You know that if it's raining outside, then you should definitely take your umbrella with you, but otherwise you don't need to take the umbrella, right? So basically the same can be said for your code. Suppose you've developed a game, and wouldn't it be nice and reasonable for you to add some functionality that if you press one of the arrows, your unit will move to that particular direction which you just specified? Simply giving you some control over what happens when a user presses some button, some key on your keyboard. And basically so far you didn't have any control over your program. You simply executed one command after the other. And that's something very important for us as the future developers, to know how to control things in our program, as well as to control things in our life. And so to teach you this topic in the most elegant way, let's take a look at a couple of quick and easy examples that will explain to you guys the logic behind it, as well as demonstrate when and why we would like to use conditions. So grab yourself something nice to drink, and here we go. So when will we want to use conditions? In what situations? Think, for example, that you would like to develop a program that will get your grade on your last exam. And suppose you would like to make this program a really cool one, such a program that will print congratulations message to the screen if you've actually passed the exam. But if you didn't pass, meaning that the input grade was insufficient, let's call it this way, you will print a failed try again message. And I would like you to take a couple of minutes to just think of this question. Could you accomplish it? Do you think you can write the code for it? Right now? So give it a shot, would you? And once you're back, basically what we can see here on the screen is that we have two different programs on the left and on the right side. And both of these programs read input from the user, and then one of these programs prints congratulations message to the screen, while the other one prints failed try again message. But if you take a look at them separately, they are not so useful, right? That's why we should aim to combine them into just one program. So we will take the failed try again message and just move it to the left, just add it to this program. And now we have both of these messages just in one place. But as probably you can see, unfortunately, if we try to run this program as is, you will simply see that you're getting an input from the user, which works fine, and then you just print congratulations as well as failed try again message. And that doesn't make any sense though, to print both of these messages one after the other. So guys, that's exactly why we need some control here. And this control is actually something new. We haven't used it in previous sections. We didn't see any examples in which we were testing any conditions. All we were just doing is simply running some lines of code, getting inputs and using output commands one after the other. So how should we add this control to our program? And it basically should work like this. In both situations, we will still need to read some input, right? So this part is a must, and it has nothing to do with any condition. And now comes the real question. How will you print congratulations if the received grade equals or higher than, let's say, 60, and print a failed try again message if the received grade is lower than 60. So for that we will need to ask the help of this guy who will be in charge of all the control flow in our program. He will decide on what path should we take next based on the result of some condition. So basically, if grade equals or higher than 60, meaning that the result of this condition is true, then we will run the code on the left side and print congratulations message to the screen and be very happy about it. But if the result of the condition is false, we will run the code on the right side and print a failed try again message and be very, unhappy about that we failed the test. So basically all this guy does is simply deciding what parts of code, what specific commands should be executed based on the result of the given condition. In this case, it's just if a grade is equals or higher than 60. So once again, just to make that clear, if the grade is higher or equals to 60, then we will run the code on the left and print a congratulations message to the screen. Otherwise, if the grade is not enough to pass the exam, we will run the code on the right and print a failed try again message. So now we simply do not print both of the messages as we've done it previously. We are just executing the relevant part of the code based on the result of this condition. So this is it for this video, guys, and I really hope that by taking a look at this pretty simple example, you've got the point and the reason why we need to use condition and control flow. And now let's see how we can take this example and implement it in our programming language. So I'll see you in the next video. What is going on, guys? And now that you're familiar with what are conditions and what they are used for, let's see how we can use them and implement them in C programming language. Let's start with our previous congratulations example where we had to get a grade as an input, and if this grade equals or higher than 60, then we just printed out congratulations. Otherwise, printed out a failed try again message. And if we know that we write this program in C language, let's first of all start with our well-known parts. So let's use the includes, include stdio.h and include stdlib. These are basically the two default includes that we've seen in code blocks in our code examples in the previous videos. And now we also know that we need some starting point, right? Perhaps we can also write this main thing already, the int main and the curly brackets to hold the block of commands. Great. And now we know that we have to get the grade as an input from the user. So let's first of all declare this variable, use int grade. We created a variable called grade and it's of type int. And then we will simply read the value from the user using scanf and hold this value inside of this variable. And up until now, everything seems to be as usual, right? Nothing new. So I think that's the time we should add the condition. And actually that's pretty simple. We just write the if statement and afterwards we specify the condition in the parentheses. So the condition in this case is simply if grade equals or higher than 60. And now we can specify the commands that should be executed once the condition happens to be true. So in this case, we should simply use the printf command to just display a congratulations message on the screen if the grade is actually higher or equals to 60. So that's all good and nice, and if we currently build and run this program, then this program will be just capable of printing out a congratulations message only if the result of the condition is true. If the result of the condition is false, alright, so basically nothing will happen here. The program just will read the value from the user, but it will not print anything to the screen. You may try to run this code at home, simply enter, 50 and see what happens. And you probably will see that nothing will happen. So that's why you would like to specify in the condition itself what commands should be executed if the result of the condition is false, right? We have here what will happen if the result is true, if the result of the condition is true. We also want to specify what will happen if the result of the condition is false. So how can we do it? How can we print the failed try again message to the screen if the condition is false? You simply should add the else section, meaning all the commands that will happen if the grade is less than 60. So then you will just print failed try again, and there you go. And actually that's pretty simple, right? Nothing complicated, just an if and a bunch of commands that may be executed based on the result if it's true, and an else, some other commands that may be executed if the result of the condition is false. So now I want us to get over this code line by line and make sure that we fully understand its flow, meaning what lines are going to be executed before and after, and simply how the program, your computer is going to execute this code. And before you finish, just don't forget to add the return 0 at the end to specify that the program has been terminated successfully. Alright, so the steps are as follows. We first of all start in the main block. Then we declare our first variable, the int grade. Then we read the value from the user by using the scanf function, and let's say that the value in this case was, I don't know, something like 90. And now we should just use the condition and ask if grade is greater or equals to 60, which happens to be true, and if that's the case, we print the congratulations message to the screen. And then, of course, we skip the else part because it should only be executed when the condition is false, which is not the case. And you just return the 0, and there you go. That was basically the flow for how your computer will execute this code line by line if the grade received from the user will equal to 90 in this case. And now let's take a look at the flow of the program when we receive a grade that is actually less than 60. So you create a variable as previously, and then you read the value of the grade, which in this case we assume that it will be just 50, let's say. And then you come to the condition section, which in this case happens to be false, right? 50 is not greater than 60. So if it's not true, you don't run the print congratulations message to the screen. You simply move to the else section, and now you execute the commands of the else block. You simply print failed try again message. Then you move on to the return 0, and there you go, your program is complete. So that basically was, guys, the second flow of how the computer will run this code if a given grade from the user is actually less than 60. So it will not run, it will not execute the code under the if section, it will simply go to the else and just execute the printf command stated there. So now you know the flow of your code when using control flow mechanism. It's a very important concept, guys, and I'm glad that now you know the general concept as well as how it is being executed and implemented in C programming language. I wish you good luck in this section, and I'll see you in the next video. Bye! What is going on, guys, and welcome back to another example. And in this video we are going to write a program that will get two values, two inputs from the user. Let's call it num1 and num2, and then the program will simply display the maximum between these two values. So simply saying, we are going to ask the user to insert two numbers, and then we are going to read them and store them in two variables, let's say num1 and num2. So for example, if the user said that num1 is going to be 5 and that num2 is going to be 7, our program in such a case should just print the following message: max equals to 7. Is it okay so far? Just printing out the highest number between the two. And basically you cannot do it without using conditions. I guess you can try, but most likely you will encounter with some difficulties on the way which could be solved very easily using conditions. And just to note, guys, that we cannot just print to the screen both numbers. I mean, we cannot print just 5 and 7 and let the user see both of them and decide for himself. That's not the goal of this program. We don't want to print them both. We just want to print the one with the highest value. And that's exactly why we need to make some comparison between these two numbers, and based on the result of this comparison, of this condition, we should print the appropriate message to the screen. So we need to ask the following question. If num1 is greater than num2, and if that's the case, meaning if the result of the condition is true, then we should print to the screen max equals and the value of num1. Otherwise, else, we can conclude that num1 is not greater, not higher than num2. So for sure we can say that num2 equals or greater than num1, and we can print the following message: max equals and specify the value of num2, which in our case is simply 7. So you check the condition if num1 is greater than num2, and based on the result of this condition, you do one of the following options. If the result of the condition was true, then you simply print max equals to num1, as you can see on the left side of this branch. And if the result of the condition was not true, which means it was false, because a condition result can only be true or false, it cannot be maybe or I don't know result. And if it was false, then we will have to run another code that is associated with this result and simply print max equals to the value of num2, which you can see on the right side of this branch. So that's it for this video, guys, and as always I want to give you as much practice as possible. So let's take a quick look at the next video where we are going to briefly go over this exercise in our programming language. So I'll see you there. What is going on, guys? You're on AlphaTech C programming course. And in this video we are going briefly to go over the implementation of our last example where we discussed how we are going to find the maximum between given two numbers. So first of all, as usual, we start with adding the includes. Then at the int main section, your entry point, create two variables num1 and num2 to hold the values read from the user. Then we should print some guiding message for the user that will help him in understanding exactly what he should do. And now we are going to read these two values one after the other to use two scanf functions. When the first one reads the value for num1 and the second scanf function for num2. And now we use our condition if num1 is greater than num2, and if that's the case, we know that num1 will hold the maximum, right? That's why we should print its value. So we simply use the printf and we just specify max equals to %d, and instead of %d we know that it will be replaced by the value of num1, which is in this case the maximum value. Otherwise, else, we will print the value of num2 because we know that definitely num1 is not greater than num2 in this case. And at the end, of course, we will specify the return 0 that simply tells that our program has been terminated successfully to the operating system. Alright, so I hope the structure is clear to you guys. And now I want us to go over the flow of the code line by line, exactly as we've seen it previously, to see the exact commands that are being executed for the two different examples. So all the lines of code until the condition are nothing special. We already know exactly how to do them and how to write them, nothing special here. So let's just assume that num1 in this case will be 10 and num2 will be 5, okay? Meaning that there will be two variables behind the scenes, num1 and num2, and num1 will hold the value of 10 and num2 will hold the value of 5. And now let us use the condition and check if the value in variable num1 is actually greater than num2. So if that's the case, we are going to execute this line of code. And basically once we've executed this command, we are going to skip the else part and just return 0 as we always do. And we can actually say that that's it. Your program found out what is the maximum between these two values when the result of the condition was true. Alright, good job guys, I hope you keep up with the pace. I tried to summarize this topic, but yet to give you a lot of details, a lot of information, and to go with you line by line and show you actually how these conditions are actually executed behind the scenes. So I hope you're with me on that. So just to summarize all of these execution, if we've used two numbers 5 and 7, then this message of max equals to 7 will be printed on the screen. And now let's see the flow of the program if the value of num1 is not greater than the value of num2. So the steps are pretty much the same as previously, starting at the main, reading the values from the user. Let's say that here the first value will be let's say 3, which will be stored in num1, and the second value will be 5, which will be stored in num2. So now the result of the condition, if num1 is greater than num2, will be false in such a case, right? And if it's false, that means we go to the else section right away. We simply skip the previous printf, right? Because it relates to the situation where the condition was true. So now we should simply execute this particular printf and just specify that max equals to %d and give the value of num2, because we know that currently num1 is not greater than num2. That's why we came here to the else section. And there you go. You can try running this code on your own, use a couple of examples, use a couple of different values, just play with it a little. Make sure that everything works just as you've expected it to work. And also try to check and understand what will happen, what part of the code will run, and basically why, if the user uses two numbers which are the same, for example 5 and 5. So as always, thank you guys for watching, and I'll see you in the next video. Hi there guys, in this video we are going to talk about relational operators. Well, the name itself is kinda scary, but there is no need for panic just yet. Relational operators are used in conditions and they simply tell you how you are going to ask a certain question. For example, how you are going to ask if a grade is higher than 80 in our programming language. And actually we've seen a couple of examples in the previous videos where we used these relational operators, probably without even noticing that. And to tell you the truth guys, you as a future programmer, you must be familiar with all of these terms that we've used so far and all of the terms that we are going to use in this course. And that's why in this video we are going to talk about it in more detail and use a little bit of more formality. So we talked about different rules that should be followed in every programming language. You do remember that, right? So the same goes here. There are things and rules that should be applied when constructing conditions. Now you see guys, in most of the programming languages, when you would like to ask a question, it won't be simply enough to ask for it in English, something like if grade is greater than 80. So we are interested in constructing the conditions in our programming language, just like we've seen in previous examples, and that's exactly the place and the time when we would like to use relational operators that will help us with this task. So relational operators are just these signs which you've probably seen most of them somewhere before, maybe even on your math classes. And the first one, the greater than, helps in constructing a condition to check if the left side is greater than the right side. Then we have the greater than or equals to, which is pretty much the same. It simply checks if the left side is greater than the right side or if the left side equals to the right side. So if either of these options happens to be true, then the result of the condition will be true. So in most cases, if we would like to ask a question like if grade is greater than 80, we are probably going to do it in this way. We are going to use the greater than relational operator sign and simply put the grade, which is a variable, on its left and the value of 80 on its right. And if this condition happens to be true, meaning that grade is greater than 80, we are going to execute some of the following commands that we would like to execute. And the same goes for the less than and the less than or equals to signs. They are pretty much the same as we use the greater than. The less than checks if the value on its left is less than the value on its right. And if that's the case, the result of the condition is going to be true. We also may have times when we would like to check if the user has done a great job on his last exam. So probably we are going to check if the grade was, for example, let's say 100. So for that we are going to use the equals to sign. Please note that there are two of these signs right here. And when they are used this way, when they come in this pair, they check the equality between what is on its left side to what is on its right side. Otherwise, if you would have used just one of them, then you know that it won't be used to check any condition, but rather it would simply be an assignment operation, like we've seen in the previous videos and in the previous section. So that's an important note, guys. Please make sure you do not mess around with this. And here is an example of how to use the equals to logical operator check. So you use if grade, then you use the equals to sign, and you use 80 or 100 to just check that you did grade on your last exam. And lastly, we also have the not equals to sign. This operator simply means that if we have it as part of our condition and the value on its left does not equals to the value on its right, then the result of the condition is going to be true. The same as equals to, just the opposite. And if you would like to write a condition to make sure that you didn't run out of cash, meaning that we don't have a zero at our account, you should use the not equal sign just like this. And let's hope that this condition shall always remain true. Definitely not less than. Don't let it be less than 0. That's a problem. Alright, so this is it for this video. Now we know what are relational operators and how they can be used, and now we are ready to move on to our challenges. So I'll see you there, guys. What is going on, ladies and gentlemen? That's time for a challenge, and your task is to write a program that checks whether a given number is even or odd. And basically what you have to do here is to develop a simple program that will read some integer value from the user and find out if that given number is even or odd. You should simply use some condition that will check if the number is even or odd, and then, based on the result of the condition, it will print out a corresponding message. For example, if the number is 5, then we should print 5 is an odd number. But if the given number was, for example, 20, then we should print 20 is an even number, right? So I hope you got the idea, and that's actually the first exercise that you're probably doing using the new topic of conditions on your own. So take your time, and I'll see you in the solutions video. Good luck! So this exercise should be very easy and intuitive for you, and actually I hope that you got to this video after you've tried to solve this exercise on your own. You gave it a shot, You tried to run some commands, even if that doesn't seem to be working out as you expected. You tried to fix some bugs, you tried to run this code once again, and that's okay, don't be afraid of it. That's how we learn, guys. And now let's go over the solution together. Basically, this exercise is pretty straightforward. First of all, we need to understand first the difference between what is an odd number and what is an even number. And the rule to find it out is as follows. Basically, if the number, alright, if the number can be divided, I'm writing it in the comments here, can be divided by 2 without a remainder, alright, then in this case the number is going to be an even number, alright, an even one, an even number. Otherwise, if the number cannot be divided, cannot be divided by 2 without a remainder, right? Without a remainder, then this number is going to be an odd number. And that's basically the whole difference between these two types of numbers, an even number and an odd number. So for example, if we have let's say 4, an example, if we have 4, 10, 20, I don't know, something like that, all of these numbers are even because they can be divided by 2 without having a remainder, alright? So all of these numbers are an example to an even number, even numbers. And for example, if we have, let's say 5 and 90 and 27, these are numbers which are odd numbers because every time if you will try to divide them by 2, then you will always have a remainder of 1, right? If you divide 5 by 2, then you will get a result of 2 and a remainder of just 1, all right? So these numbers are odd numbers. So now we know how to classify between odd and even numbers, and pretty much, I guess you got the idea. It's not so complicated for those of you who are not so familiar with what are even numbers and odd numbers, and let's dive to writing our code in C. So for that, let's first of all create, alright, I think I will remove these comments that they will not bother you. I guess you wrote them down also. So first of all, let's create a variable num, int num. Alright, and then we are going to display a nice message, printf, enter a number, alright, and then you go scanf, %d, and we are going to read a value, to read an integer value and put it inside a num variable. And up until this point, everything is similar to the previous sections and exercises that we've seen so far. So now we are going to insert our if condition, and we are going to use it if, and here we are going to specify the condition that checks if the division of num over 2 has a remainder of 0. And if that's the case, we know that num is even, alright? So we are going to print a corresponding message, so printf %d is even, and the \n here, and instead of %d, we are going to replace it with the value of num itself and semicolon at the end. And if the condition result is not true, alright, if there is still a remainder, if we divide num by 2 but we got a remainder, so we use the else section, and if that's the case, we are going to print that the num itself is odd, alright, so %d is odd, \n at the end, num, pretty much the same line as we have used right here. And there you go, we've written a program that checks if a number is even or odd, and based on the result of the condition, it prints out a corresponding message. So let's try to run this code. Let's build and run it. Alright, there you go, enter a number. Let's see, we know that, for example, 10 should be an even number. Enter a number. 10 is even. Great. And now let's try to use something that is odd, for example 5. There you go, 5 is odd. Alright. So basically that's it. We could just maybe add some message here. Num is an even number to make it more clear number, and also num is an odd number, just some formality, all right? So this is it for this video, guys, and we checked, just to summarize everything up, we checked if the remainder is 0, and based on the result we printed out that a number is an even number, otherwise it's an odd number. Another solution, I will just put it here, let's copy and paste that. We could have checked if the number has a remainder which is not 0, and if that's the case, we are going just to switch places between the printf commands and print that the number is odd, otherwise it's even. So that's this part of code and this part of code. Basically they do just the same, it's just that the condition is formulated a little bit differently. Here we check for the equality, and here we check if the remainder is not equal to 0. What is going on, guys? And in this exercise we are going to write a program that gets two floating point numbers and prints out which one of them is the maximum and which one of them is the minimum. In other words, the program should find out, probably by using some sort of comparison, which number is higher and which number is lower, and print the corresponding messages based on the result. So for example, let's see if we insert two numbers, the first one is 3.5 and the second one is 5.2, then we expect that the program will print the exact following message: maximum equals to 5.2 and minimum equals to 3.5. Alright, so I hope you got the idea behind it, and now what I want you to do is to take a couple of moments and give that a try on your own, and then come and check out the next video as we solve this exercise together. So I'll see you there. Alright guys, so let's get down to business right away. So we want to write a program that will find the maximum and the minimum values between two numbers, alright? So for example, let's make a quick example here. If we have two numbers, these numbers should be of a floating point type. So for example, the first number is 3.5 and the second number is 5.2, like you've seen previously. Then we want to print a message like this, that we want to print two messages actually. The first one is maximum equals to 5.2 and the minimum equals to 3.5. So these are the two messages that I want to see on the screen. All right, so let's go. First of all, let's remove these comments. And we need to create two variables of a floating point type. So we just type float, num1 and num2. Then, right after we've created them, we will read the values from the user and store them inside of variables num1 and num2, alright? So printf enter num1, semicolon at the end. And also we will print the same message for num2, so printf enter num2. And now we are going to use the function scanf to read the value from the console and store it inside of num1. So for that we are going to use scanf % not d, but rather %f, because we are using a floating point type. And then we are going to specify the address of num1, and we will do the same also for num2, alright? So num2, scanf %f, and store the value inside of the variable num2. And now at this point we have both of our variables holding two values, and we can't just print them right away, right? We cannot print maximum equals to num1 or minimum equals to num2, because we don't know what each variable holds, either it's a higher or a lower number. So for this we are going to use a condition that will check which variable num1 or num2 holds the higher value. So it goes like this: if num1 greater than num2, then we know for sure who is the maximum between these two numbers. And also we know who is the minimum between these two, right? Because either it's one of them is either it's higher than the other one or it's lower. Basically, we are not taking here the case if both of them are equal, all right? We are just leaving it aside for now. So if that's the case, we are going to open a block of commands, all right, an associated block of commands that will be executed if the result of this condition happens to be true. So we are going to print two messages here. The first one is printf, and we are going to use maximum value equals to %f. Make sure you don't specify here %d because we are using a floating point type. And of course a \n at the end, and we are going to specify here that instead of this %f, we are going to use num1 because it's greater than num2 and it holds the maximum value. And also we are going to write pretty much the same message just to explain where the minimum is stored. So minimum equals to %f also \n, but now instead of num1, we know that minimum will be stored in the variable num2. So the value is going to be stored in num2 because num2 is definitely less than num1. So it will hold the minimum value between these two numbers. And now we should also specify the else section. What will happen if the result for this condition happens to be false? So here we go again. We specify a block of commands, and we go to print out that the maximum right now, if this condition is false, then definitely num1 is at least equals to that num2 at least equals to num1, or it may be higher than num1. Then we will assume that maximum is num1, so %f \n, and we specify the variable num2, and we go the same way. Let's copy and paste that the minimum in this case will be num1. And there you go, we can say that we are done with this program. And if the result of the condition, just to summarize it once again, if the result of the condition is false, meaning that num1 was not higher than num2, then we would print the maximum value of num2 and the minimum value of num1. Just last thing to mention here, no, that's okay, we talked about it. So let's just build and run it. So num1 is going to be 3.2 and num2 is going to be 5.7, let's say. So here we can see maximum equals to 5.7 and minimum equals to 3.2. If we try to do another example, let's say that we use num1 equals to 10.5 and num2 equals to 9.6, then we know that the expected maximum value is 10.5 and the minimum is 9.6. So let's see if that's the case. Yes, and our program actually finds out exactly what is the maximum and what is the minimum between these two numbers. So you've developed quite a nice program here, and I hope you're proud of yourself. You keep moving forward. So that's it for this video, guys, and I'll see you in the next one. Have a nice day. Welcome back, ladies and gentlemen. My name is Vlad, and this is an AlphaTech programming course. And in this challenge, you have to write a program that reads from the user 3 values. And based on these 3 values, the program is going to find the maximum and the minimum between them. And although we've seen how that can be done just by using 2 variables, and it wasn't so complicated, right? Now we are asked to find the maximum and the minimum between 3 variables, not just 2, but 3 variables. So for example, if we take a look at these 3 numbers, 5, 3, and 7, I want the result, the output on the screen, to be something like maximum is 7 and minimum is 3 among these 3 numbers, alright? And for another example, if we have the three numbers 2, 5, and 1, then it's obvious that the maximum is going to be 5 in this case and the minimum is going to be 1. So I hope the instructions are clear to you and that you have some idea of what pretty much you should do to solve that. And just a side note, you can solve this challenge in a couple of ways and in a couple of different options. And although some of them may work eventually, yes, I would like still to ask you to think of an optimized solution, alright? Meaning, think of a solution to find minimum and maximum among these three numbers in the most efficient way when you use as few conditions as possible. So bear that in mind, and I wish you good luck, and I'll see you in the next video. What is going on, guys? So in this exercise, we were asked to develop a program that gets three values and finds out which one of them is the maximum and which one of them is the minimum. So to do it, let's just add another example, all right, as we are doing always in these challenges. So 5, 5, 3, and 7, if we have these three numbers, then the output that we will see on the screen is maximum equals to 7, and that minimum equals to 3, all right? So another example you probably seen on the challenge introduction. And now I just want to let you know that this exercise is actually not so difficult because we know how to find out the maximum and the minimum between two numbers, so we just need to extend it a little bit. But also the main idea here was to also find out the maximum and the minimum between these three numbers in the most, let's say, in the most appropriate way. So we could use just something like that. Let's start with the basic template that we will use in all of the cases. So first of all, let's create our three variables, int a, b, and c. I'll call them this way. And now let's print some nice message to the screen. Let's go like printf, enter first number. Let's read it. Let's read this number. Let's read this value using this scanf function, %d, and place it inside of a. Okay, so copy and paste these two lines just to make it quicker. I don't recommend you to copy and paste anything in your code. I'm just doing it right now because I want to summarize and to use the video as fast as I can to explain it to you guys. So let's use Control V, enter second number, and enter third number. Here we are going to use B, and here we are going to use C. So A, B, and C are our three variables which hold the values that the user inserted, the three values that the user used. So now once we have all of these values, we are ready to move on to using some conditions. So in this part, this section, there is a couple of different ways that you can solve it. All right, probably you started with one option and then you realized that you may use another option, and one is okay and one is not. So there are a couple of approaches here, and you can do something like that. If a is greater than b, then we are going to use a nested if condition, and we are going to write it like this. If b is greater than c, then we know for sure that the minimum value is going to be stored inside of the variable c, right? Because a is greater than b, b is greater than c, then definitely C is less than B and A. So we can use something like this, printf minimum equals to %d, and use the value of C, all right? And if that's not the case, we are going to use an else and printf that the minimum right now is going to be inside of variable B, in B, okay? Because if b is not greater than c, then b is the smallest value probably between these three values. And there you go, that's how you find the minimum value. Semicolon at the end, don't forget it. And basically you can see that what it took us to find out what variable, and basically you can see what it takes to find out in this approach just the minimum value. I'm not talking about the maximum value, and I'm not talking about the else for this condition. If we are going to use here another else, we are also going to copy and paste all of this part, and that is just to find out the minimum between these three numbers, and then you have to specify how you will find the maximum between them, and you can see it's just a mess. You can see a bunch of if and else and conditions and nested conditions, and that's not the optimized way that you have to solve this problem. So at this point you should start thinking about how you can solve an exercise. All right, at this point where in your programming career, you should think of how can you solve this program elegantly with as much less lines of code as possible, and to make it more clear to you when you even read it. So we will remove these lines of code and we will do something like this. So please stay tuned at this one. It's very important, the notes that I'm about to give you right now. We are going to create another two variables that will help us to solve this exercise, and these variables are going to be int max and min. All right, two variables, maximum and minimum, that will hold the maximum and the minimum values correspondingly based on the results of different parts of our code. So we will assume here at this line, we will assume that maximum will be equals to the value inside of variable a, and that the minimum value will equal to variable b. And that's just an assumption that we are doing to make sure that we are not using a lot of if-else conditions. So let's use the first condition, if, and ask if. So I hope the assumption, you got the whole of it. You understand why we use this assumption here instead of using the else section right beneath the if condition. So at this point we know which value between a and b is higher and which value is less than the other one. And we are going to ask another condition and to see if maximum, if the max value is less than c. All right, we know that max holds the maximum value at this point between a and b, and now we are going to see if either it's a or b. Is if it's less than c, then c should be inside of this variable, inside of max. So if that's the case, we are going to say that max equals to c, right? Makes sense. But if it's not the case, should we use the else statement here and to specify what? If it's not the case, if max is not less than c, if c is not greater than max, then max already holds the higher value. It holds either it's b or a. It depends on which one of them is greater than the other. So there is no need for the else section here. But what we would also like to do is to see maybe c is less than the minimum. And if that's the case, if c is less than the minimum, and the minimum at this point holds the value that the lowest value between a and b, if that's the case, if c is less than one of these value, the lowest of this value, we know that minimum should be equals to c. Should equal to c. So now after this line, after this 27th line, we know that maximum variable holds the maximum value between a, b, and c, and that minimum value holds the minimum value between the lowest value between a, b, and c. And now we can print the corresponding message, printf maximum between three numbers equals to %d \n and \n, not m, and specify the maximum variable, and also do the same for the minimum. Here we specify the minimum, and here we say minimum. All right, so you see this simple, easy, straightforward structure just by using three if conditions, without even using any else condition and without using nested conditions. So let's build and run it. Let's see how it looks like. And our previous example was something like 5, 3, and 7, right? And we expect that the maximum will be 7 and the minimum will be 3. So the maximum between three numbers is 7 and the minimum is 3. Now let's see another example. Let's see the second example that we had, just to make sure that everything is running as we expected. And it was like something like 2, let's see, 5 and 1. So the maximum between these three numbers is 5 and the minimum between these three numbers is 1. So there you go, guys. You can see that we took another approach, and I guess you first of all thought of the previous approach that we tried to use in these exercises before, using the conditions and using the if, else, and the nested conditions. And we've seen that it makes a lot of mess and a lot of unnecessary checks. It also consumes more time if the program is going to be, I don't know, a lot more variables are going to be involved in this exercise. So at this point, it's very important for you to start thinking about how to optimize your solution and how to find the most elegant and quickest and easiest to read way to solve any exercise. So thank you guys for watching, and I'll see you in the next video. What is going on, guys? I hope you're doing well, getting a hold of all the new concepts we are learning in this course. And in this video, we are going to move even a step further with the control flow topic. So let's first of all review what we've done so far. We used the basic if condition, and based on its result, which was true or false, we've executed some associated commands depending on the result of the condition. You do remember that, right? And we've seen a couple of examples, like when we wanted to find out what is the maximum value among two given numbers, num1 and num2, we asked if num1 was greater than num2. And if that's the case, if the result of this condition is true, we would have printed that the maximum is num1. Otherwise, we would have printed, alright, otherwise if the result of the condition was false, we would have printed that the maximum is num2. So we basically will run different commands, different parts of code based on the result of a given condition. And also we've seen an example where we tested out if a given number was even or odd. We've seen how to test it. We simply checked if the remainder of the division by 2 will be either 1 or 0, and then based on the result we printed out if the number is even or the number was odd. Alright, so I hope you got the whole idea of this, because it's very important that you didn't miss anything that we said previously. It was just a reminder for you guys before we move on, right? We're moving forward in this control flow topic. So now what I want us to do is to take a look at the following example. So let's take a look at this exercise, and it goes like this. First of all, get a grade from the user, alright? Once again, get the user's grade. And if the grade is 80 or higher, we will print excellent job message. Otherwise, if the grade is not 80 or higher, meaning it's less than 80, but yet it may be 60 or higher, we will print not bad, but study a little bit more next time message, alright? And if the grade is less than 60, meaning the two previous conditions were not satisfied, we will print the following message: oh, you didn't pass, something like that, try again next time, alright? Do your best for the next exam. So if you take a closer look at this exercise, and you can see basically that a simple if-else statement, just as we used previously, is just not going to be enough in this case. We've used here some more, let's say, modified approach, the else-if approach, which is also sometimes called a nested condition. And the reason for that is because we nest one condition into the other. And let's see basically how it looks like. The first condition was if grade is 80 or higher, and then the else of this result, meaning the grade may be probably is less than 80, but we still use the else if statement, and we checked out if the grade Maybe it's less than 80, but it still may be 60 or higher, alright? And if that's also not the case, then we are moving to the fourth option in this case, when we have the grade less than 60. So just to make it clear, let's go over the flow once again, step by step, alright? So we got our grade input, that's the first step, get the grade from the user. Now we use a condition to see if the test was good and if the grade is 80 or higher, alright? If grade is 80 or higher, this is our condition in this case. If the result of this particular condition is true, then let's simply print some congratulations message and print to the user some excellent job, you've done great on your last exam. Alright? But if the result is not true, which leaves us with the fact that the result is false, and now at this point, as opposed to different examples we've seen so far, we would like to use another condition, a nested condition. So we use the following condition to ask if grade is 60 or higher. Maybe it's 60 or higher, right? It makes sense. And we want to know if that's the case. So we know that at this point the grade is definitely less than 80, but now it can be in the range between 60 to 80 or less than 60, and that's exactly what we want to find out. And we want two different messages, printed for these two options. So if the result of this condition is true, then we know that the grade is between 60 to 80, and although that's not the best grade that you can get on your exam, that's not so bad, right? So in this case, we would like to print not bad message and you've done pretty well, not bad. And otherwise, if the result of this condition happens also to be false, then we can definitely say that the grade is less than 80 and also it's less than 60. So we will have to print a failed try again message and ask the user to give that another shot, to give another shot at the exam. So hopefully he will pass next time. And that would basically be it, guys. And that's how you use nested conditions in programming. And you can embed them at any stage you like, as many times as you like. Just make sure that this whole structure makes sense, alright? And now once we've mapped every sentence to this representation on the left, this graphical representation on the left, I want us to take a deeper look and see how it can be done in our programming language. So let's take a look. Alright, so now let's take a look at how it can be done in our programming language. So first of all, let's start with all the formality, just include everything that you need, then create the main function, int main, open up the curly brackets, and now let's create a variable that should hold the value of your grade. So just use int grade, alright? We'll assume that in this example grade is going to be of an integer type. Then we are going to read the grade from the user by using the scanf function, but before that we are going to print just some guiding message to show the user what we want him to do. So printf and enter your grade. Then we have the scanf function that takes an integer value from the console and put it inside of the grade variable. Now we want to check if the grade is real good, for example if it is 80 or higher like we've seen in the previous example. So we just use the condition, the if condition, if grade is greater or equals to 80. And if that's the case, we should print an excellent job message. So we just go with the printf excellent job \n at the end of it, and we are done with this result. If the result is true, then the message is an excellent job printed to the screen. Otherwise, meaning if the grade is less than 80, we know that there are two messages that may be printed. Alright, so the first one would be if the grade is less than 80, but still we want to check if it's above 60, if it's 60 or higher, right? So for that we're going to use another if statement, a nested if, and check out another condition. If grade equals or greater than 60. So if the result for this condition happens to be true, that means that the grade is somewhere between 60 to 80, right? It's pretty much in this range, which is still okay for our exam. And if that's the case, we are going to print not bad message to the screen. But if the result for this condition happens also to be false, then we can say that you failed the test and you got less than 60. So we use the total, the last else, let's call it this way. And what message should we print in this case? Then in this case, we should simply use a no, you didn't pass the exam and try your best next time, alright? Just pretty much a failed try again message. So this line, this last printf command, will only be executed if the grade is not equals or greater than 60, as well as if it's not greater or equals to 60. To 80 and to 60, to 80 and to 60, meaning that this line, this last printf command is going only to be executed if the grade is less than 60. And the second printf command, where we can see that a not bad message is printed out of the screen, is going to be executed when the grade is in the range between 60 to 80, and the first message is only if you studied well for your exam and you got a grade that is 80 or higher. Alright, so I hope that makes sense to you, all this structure, all of this usage of nested if conditions. And lastly, what I want you to do for this exercise, for this video, better say, is that I would like you to give it a try to solve the above example on your own, alright? Just let yourself feel the coding process, check out if you've got any errors, try to fix them on your own, compare the results with what you can see right now on the screen. But this process of learning, and it's basically will sharpen your skills in programming, and you need it. So make sure to check that out, give it a shot on your own, and I'll see you in the next video, guys. Hello and welcome back to another AlphaTech Academy video. My name is Vlad, and in this video we are going to talk about logical operators. So we use logical operators in our day-to-day life without paying much attention to it. For example, if we can take a slice of bread and some spread, then we can make a delicious sandwich. Another example, we can say that if it's raining outside or it's cold today, then you should take your jacket with you. So if we take a look at the first example, we can see that it has basically two, let's call it this way, two subconditions. The first one is if we take a slice of bread, this is the first condition. And the second one is if we take some spread, and if we want to use some formality here, then these two subconditions are called operands. So there is the first one and the second one. And these two subconditions, these two operands, basically what they do is they form, by using a logical AND operator, they form a new condition. And this combined condition may also be true or false based on the status, on the result of these subcondition, based on the result of these two operands and the AND logical operator that we use between them. And now the question that remains is, how can we decide if the result will be true or false? And for that we can use a truth table that will help us with the decision. And this truth table is very straightforward once you understand it. So let's suppose that we have this little nice table with a couple of columns and a couple of rows, and we will say that the first column will represent the status or the result of the first operand of the first subcondition, which we took, for example, that it stands for if we take a slice of bread, okay? So that's the first operand. And the second column in this truth table will represent the status of the second subcondition of the second operand, which stands for if we take a spread. So the first condition is if we take a bread, okay? And the second one if we take a spread. And each of these operands may be either true or false, and basically there is a total of 4 optional combinations between them. Either both of them are true, or maybe one of them is true and the second one is false, or both of them are false. That's it, right? Either both of them are true, or the first one is true, the second one is false, or otherwise the first one is false and the second one is true, or both of them are false. There are no other combinations that you can do with these 2 subconditions, all right? So these were just the operands of our overall expression. Now let's see what would be the result of using an AND logical operator on both of them. So if you have a slice of bread and you have a spread, then it means you can make a sandwich. So it means that if both of these subconditions are true, then the overall result is true. You can make a sandwich. But if you don't have at least one of them, either it's a slice of bread or a spread, then you cannot make a sandwich. You will have just one of the ingredients, but it won't be sufficient to make your favorite sandwich, right? So the overall result in this case is that both of them are going to be false. And lastly, if there is no bread and no spread, then it is obvious that there is no sandwich. So the result is definitely going to be false. And now what we've done is we've simply created a truth table for the AND logical operator. So whenever you're going to work with an AND logical operator and you have a couple of subconditions, you can use this truth table to help you understand what will be the result, the overall result of the condition itself. So once again, based on the status of the given operands that you can see in these columns, if you use the logical AND operator between the 2, then the result is going to be exactly as you can see on the last column, on the right one. So I hope that's clear to you guys and you understand everything we've just discussed. And just to make sure that you do, I'm going to give you another example using the AND logical operator. So let's say that you want to ask for some money from I don't know whom, maybe your parents, your friends, your colleagues, or anyone else. And since you know they care for you, you know they will help you. But they will help you only if you have less than, let's say, $50 in your wallet. And also, they will not just give you the money based on that condition alone. They also want you to succeed in school, so there is a second condition which says that you have to get a grade higher than 90 on your programming exam. And if both of these conditions are satisfied, then you will print the following message: give me some money please, I've earned it with a high grade and nothing in my pocket. So pretty funny example, but let's try to look more into it. So this message will be printed only if both of these conditions happen to be true. So if 1, we have less than $50 in our wallet, and 2, if we've got a grade higher than 90 on our last exam, only then we would print this message asking for some money in reward. So I hope the example is clear to you guys and you understand the logic behind using an AND logical operator. And now what I want to do is to talk about the second example, a sentence we probably mentioned at the beginning of the topic, I guess, and it goes like this: if it's raining outside or it's cold today, take your jacket with you. Let's try to construct the OR logical operator table ourselves, shall we? So first of all, we can say that the first operand, the first subcondition, relates to if it's raining outside, and the second one relates to if it's cold today. And if both of them are true, we can say that we definitely should take the jacket, right? If both of them are true, if it's cold and if it's raining, then we should take our jacket with us. We know that if it's raining outside, then it doesn't matter if it's cold or not, then we should also take a jacket with us. Similarly, if we know that it's cold outside, then it doesn't matter if it's raining because it's cold outside. So meaning that for both of these cases, if one condition, at least one condition, happens to be true, the result is also going to be true. So we need the jacket with us. And lastly, only if it's not raining and it's not cold today, only then you don't have to take your jacket with you. Meaning the result in this case will be false. It's not cold, there is no rain, and there is no reason to take the jacket with us. So that's basically how you create a truth table for the OR logical operator. And just to go over it once again, if either of the conditions, either of the operands happen to be true, then the overall result will be true. And just remember this nice example of the cold and if it's raining, example that we used right now, and should you or should you not take your jacket with you. And that's good, guys, and now we know how the logical OR operator and the logical AND operator, how both of them work. And now we can simply summarize what we've learned so far. So we may have a couple of operands, a couple of these subconditions, and also we may have some logical operators that are applied on these operands. And the final result of all of these, let's say, process is decided to be either true or false. It doesn't matter if it's complicated, and it doesn't matter how much operands or logical operators you may use. The final result may only be either true or false. It all comes to this in programming, okay? Eventually, that's all we have. Either true or false, and 0 or 1, and that's how programming works. So I hope this structure, the usage of these truth tables is clear to you guys. And one last thing that I want to talk about in this video is the last logical operator, which is called the not logical operator. And it's the easiest one actually. It simply takes some expression, and whatever its final result, either it's true or false, this not operator will return the inverse value. So if it is applied on a value that happened to be true, then the final result would be false and vice versa. So it simply negates the result. And once again, if this not operator is applied on some expression which is true, then the final result is going to be false. And if it is applied on an expression which happens to be false, then the final result is going to be true. So thank you guys for watching. You are on AlphaTech Academy programming course. My name is Vlad, and now we can move on to practice logical operators in our programming language. I'll see you there. Welcome back, ladies and gentlemen. Now, at this video, we are going to take a look at how logical operators may be used in our C programming language. So, logical operators, here we go. We are going to start with our previous example, which says if we got 90 or higher on our last exam, so let's write it down. If we got 90 or higher on our last exam, and if we also have less than 50 bucks, if we have less than 50 bucks in our wallet, then in this case we can ask for some money. Pretty nice example, don't you think? So we've seen the logical structure behind it, as well as the truth table behind the AND logical operator, and now we want to take a look at how it can be written in our language. So that's not a basic if-else statement that we've seen in our previous examples, right? Let's first of all pronounce this condition correctly by specifying the exact two subconditions. these two operands we can see right here, and then construct our general condition by using the logical operator. So the first condition is if we have less, let's say that's this the first condition, if we have less than 50 bucks in our wallet, and the second condition is if we got 90 or higher in our last exam. So when we pronounce it this way, we can hear that there is this and, which appears between both of these subconditions, right? And this AND word is called the logical operator, which you already know this much, right? I'm just a quick reminder. So if you want to construct some new condition, it will look something like this, okay? So let's say that we have two variables. So let's say there is int money and there is int grade, right? Int grade, and we use some messages. So enter money and grade, okay? Very simple. Then we use this kind of function to read these values from the user. So %d, and we used here the money and the grade. Nothing special so far. And now if we want to ask the condition, so we ask it this way, if, okay, so the if statement, and then we have money is greater, is less than 50, okay, so if this condition, this operand is true, and, right, we need to specify something like this, and grade is greater than 90, then do something, okay, do something. So this AND here will not work in C language, right? So instead of this AND, in C we use the double ampersands. So simply use it this way, and it's equivalent as you would have said in your language AND. So we use the double ampersands to indicate that if and only if both of these conditions, money is less than 50, grade is higher than 90. Only if both of them are true, the result of the condition, of the whole condition, will be true, and then we will do something. For example, ask for some money. Is that clear? So that's how you use the AND logical operator, and now let's move on to see how can we use the OR logical operator, which we've seen in our previous video. We talked about it in general. Now let's see how we can do it in our programming language. So it will look something like this. If money is less than 50, or so logically it would be like this, but since we are using C programming language, this will be slightly different, and instead of this OR word, we will use double vertical bars, just like this. So here you can see, and if the condition happens to be true, then we will do also something, right? I'm just showing you the difference between the AND and the OR in C language. So for the AND logical operator, you use double ampersands, and for the OR logical operator, you use the double vertical bars. So this condition, this whole condition will be true if either at least one of them is true. So if this subcondition is true, or this subcondition is true, or if both of them are true, then the whole condition is going to be true, and we are going to do something. So that's something you can see, and you remember when we talked about the truth table, you can see what will be the result based on the status of the operands. So there is a truth table for each of these logical operators. And lastly, what we have is the NOT logical operator, and in C language the logical operator NOT is specified as an exclamation mark, so it looks just like this, okay? It looks just like this body here. This is the NOT in C language. So if you put this exclamation mark before any condition, it will simply take the result, whether it was true or false, and just revert it. So for example, if we have the following condition, let's say if grade is greater than 80, then print some nice message, then printf a good job message, so good job, okay? So if this condition happens to be true and grade is higher than 80, then you are going to run this command. But if you put an exclamation mark, let's say right here, okay, and add another parenthesis, then in this case, whenever grade is higher than 80, the overall result that should have been true will be false and vice versa. Simple as that. So now this good job will be executed only, okay, because we used here the not logical operator, it will be only executed when grade is less or equals to 80. So I hope you got the point of how the not logical operator works. You simply have a true, and if the result of the condition is true and you put a not on it, then it becomes false, and vice versa. Okay, so that's basically a very summarized tutorial regarding logical operators. Basically, all the operators, logical operators and relational operators, like equality, inequality, more than, less than, and so on, all of them are very important, and you need to know how to use them for almost all of our upcoming sections. So that's it for this video, guys. Thank you so much for watching, and I'll see you in the next video. At this point, you should already be well familiar with if statements and what are the main principles of control flow. And in this video, we are going to review the code from one of our previous examples and build our way up in the most detailed explanation and learn how and when we could and actually should use switch cases in C programming language. So in this example, we tested out some conditions, and for each of these options, we've printed out a corresponding message. And if you take a closer look, you will see that we checked whether a condition is true or false for a range of numbers. For example, if we take the first condition, which is if grade is greater or equals to 80, that may be true for all numbers, which are basically 80 or higher, right? So it can be true for a variety of options, for a range of numbers. So it can be true for 80, 81, 82, 83, up to 95, 96, and so on. All numbers that are greater than 80, this condition will result in a true, right? It will be true. And then we also had the else if statement that checks whether a grade equals or higher than 60, but it less than 80. And similarly, this condition will be true for all numbers between 60 to 80, right? 60, 61, 62, and so on, up to 80. So once again, this means that these different conditions may be true for a range of numbers. And of course, we can take a look at the last condition when we use the else statement, when the grade is less, probably is less than 60. Then also here you may have a lot of other options that this condition will be satisfied, like 59, 58, 57, and so on, right? Everything that is below 60. But the thing, guys, is that this range of conditions, that's not always going to be the case. There are times when the conditions may be true just for a single value, not for a range of values. And I want to give you an additional example that hopefully will be much more interesting to you before we move on, alright? So let's talk about a grading system that works with the letters A, B, C, D, and F, let's say. And this grading system is pretty simple. Some of you may be familiar with it, but for those who are not, I will briefly explain it to you guys. So the grades here are represented as letters, and there is no precise grade like 96 or 97 or 72 like we've seen previously in our previous examples, but rather each letter in this grading system represents a range of possible grades, of possible numbers in the numerical grading system that we've seen in previous examples. So a grade A represents the range of grades, of numbers of grades from 90 to 100. Grade B represents the range of grades from 80 to 89. There is also grade C that represents the range of numbers, the range of grades between 70 to 79. There is also D, and lastly we have the F grade, which represents that you've failed on your exam. And what we're going to do now is to write some converting program which will simply get a letter from the user and then print out the range of associated grades from the other grading system. Just like we can see here on the screen on the left, we can see that we will get a letter, either it will be A, B, C, D, or F, and then we will print a corresponding message with the range of numbers, the range of values associated with that given letter. So for example, if we studied well for our exam and received an A, then we should print out the message, your grade is between 90 to 100. Or if we got a C on the exam, then we should print something like that. Your grade is between 70 to 79. Simply based on this formula that you can see here on the left, you are going to print an associated message. Is that clear what we have to do right now? And before we move on, I want to stop you guys just for a moment, alright? And let you think about how cool is that you can actually write your own program that does something you wanted it to do, right? You can think about an idea like the one we can see on the screen, and then you think about the idea and you can implement it by developing a program that gets a grade from one grading system and converts that grade to another grading system. Think about how much progress have you made so far, and I want to let you know that you should be proud of yourself. And now, with that motivation being said, let's come back to our program, shall we? So here we can see basically the template for our code. I've written it in C and just embedded it here in this presentation. We can see that first of all we create a variable called grade and it's of type char, right? We're using a character. Then we read the value of this character, and then we are going just with the if-else statements, all right? So we've talked about a case where we've received a letter A, and what should we print if that's the case? So if grade equals to the letter A, we should print that grade is between 90 to 100. Now, if we've received a letter B, we should go to this condition and print that the grade is between 80 to 89. Also for C, for D, and for now I'm not putting here in this example, I'm not putting the letter F, I'm just going with the else condition that prints out that there was an error and you didn't specify A, B, C, or D, alright? We did not include here the F option, although it's mentioned here in the printf command. So we basically can handle 4 cases, A, B, C, and D, alright? Otherwise, we are going to print an error message to the screen. So this program, this whole structure of it, if it will work, but we can say that it starts getting a little bit messy, don't you think? All of these if, else if, and then the else. If at some point, alright, you would like to add support also for grade F, which is currently not here, alright, you will need to find the exact place in code where you should add it. Maybe you should add it here, or maybe it doesn't matter, right? But you have to think about it where you should add the condition to check if the grade equals to an F. So although this code works, as we just mentioned, alright, if you try to run it on your own, then you will see that it works. There is a better, elegant approach for solving such problems, and it should be done using the switch cases. So switch case or switch statement is also a control mechanism which allows us to compare a given variable with multiple cases. And I'll show you this right now, but I just want you to take another look at this example and understand that it's getting kind of messy when we make comparisons between a given variable to a certain value, right? Not to a range of values as we've seen previously, but to a certain value. There is a better way to handle it by using switch cases mechanism. So switch case is a control mechanism that allows us to compare a given variable with multiple cases. And for a case that the mechanism finds a match, meaning the condition is true, then it allows associating a block of commands to be executed for that particular case. But these values, and remember this one, it's important, these values should always be discrete, alright? Not a range of numbers, but a single unique value, something discrete. And now I want us to take a look at how the template, how the structure of the switch statement looks like in C programming language, and then explain it in more details. So first of all, we just create the variable grade as previously, then we write the word switch, alright? We write the word switch, and afterwards we provide in the parentheses the variable you would like to check, the variable itself, grade in this case. And we know that grade should hold only discrete values, right? Either it's A, B, C, or D. We are not talking here about testing any ranges for grade. We simply want to ask if it equals to one of these given characters A, B, C, or D. That's it. So the syntax goes like this. We first of all specify the curly brackets, the block of commands that are associated with the switch case mechanism in C, and now we will specify all the cases that grade variable may be, and the associated commands that should be executed for each of these cases. So the first case refers to when the grade equals to A, so we just use case, and then we specify the value a character A. It's almost the same as you would have written if grade equals to a letter A. And you can see that right after the case we use here a colon, and it simply lets you associate a bunch of commands related to that particular case. Meaning if that case seems to be happening to be true, alright, if that case happens to be true, then we will execute the associated commands. So we will print to the screen the grade, that the grade is between 90 to 100. So here you go, you associate a bunch of commands with a given case. Just like we did previously with the if-else, just by using cases. So for now, maybe this break line, this break and the semicolon at the end, maybe it's bothering you a little bit, but just leave it aside for now, we will come back to it later on. So now we can add another case, right, because we are done with the case where the grade equals to A. We can move on to another case and specify the second case, which is case B. And now we can specify the associated commands with this particular case. It goes like this: printf grade is between 80 to 89. And also it goes the same for case C and case D, pretty much the same. You just specify the case and the value for the variable grade that you are running the switch case on, and you just specify the associated commands for each given case. So once again, you first of all specify the word case, then the value of that case, and if the switched variable value is the same as specified in the case, A, B, C, or D in this example, you should execute the associated block of commands for this particular case. So I hope that makes sense to you guys, nothing complicated here. And this simply allows us to organize the code in a little bit more structured way, and it also gives us flexibility with modifying and even adding new cases as your program being continuously developed, alright? These are some terms that you will learn in the future, but it's important for me to tell you these terms of continuous development and how you modify your code. It should always be as easy as possible and as understandable as you can make this program. So for example, if you would like to add support for F, right, for F grade, then you should just add an associated case for that without changing anything in the structure of the code, just like that, simply adding additional case and its associated commands. Alright, we are good, we are moving forward, and so we are almost done. Just last thing we should talk about in the switch statement is the default line. So this line is optional and you don't actually have to add it, but still you're very likely to use that because it is a special case which refers to what you should do if the variable was not matched with any of the other cases that were specified in this switch case structure. So to put it simple, this special default case is being executed if there was no match between A, B, C, or D in this example, just executing the default case. There was no match between these cases, we are going to execute the default case. So in our example, what do you think we should execute in the default section? We are probably going to execute some error message that will represent the fact that no case was matched, alright? So maybe if by mistake a user inserts, I don't know, a grade J, for example, then you should definitely print an error message. So it will look just like this. You just printf error, try again to let the user know that he has done something wrong. Great. And the last thing to note here is that break line, the break line you can see in every case, it's very important to understand what does it mean. So this command is added at the end of every case, and all it simply says is that if you've executed a given case, there is no need to continue searching and executing other cases, just break from this switch statement and move on. So if, for example, we have a grade A and a grade A was used, so we are getting inside of this case, you're simply going to execute all of its associated commands, all right? And then you're just going to break from the switch statement and end up leaving it, all right? You're going to leave it. And why is that so useful? Well, because if you don't use a break, for example at case A, then if you run this program, you will get inside case A, you may get inside case A, you will execute all of its associated commands. There may be more than just a printf command here. Maybe you are modifying grade, or I don't know what you're doing here. And once you are done, you will not leave the switch statement as whole, you will not leave it, but rather you will keep searching and executing maybe other cases, right? You will simply execute commands until you reach some break line or you're finished with the switch case, or you're getting to the default. So basically you will also execute the B case if maybe the grade was modified in this particular case. Maybe grade was modified and there is no break line, so you may be by mistake get inside of this case because now grade will be equal to B, and all of that will happen just because you didn't use this break line to specify that if you got inside of the case, you execute its commands and then you get out of the switch case right away. Alright? So don't leave any places for mistakes in this kind of structure. So if you will run this program, and I hope you are going to write this code on your own and try to execute it. If we are going to run it, we are going to get a message, enter your grade, A to F, we are going to insert A, and we are going to get the result of grade is between 90 to 100. Welcome back, ladies and gentlemen, to another amazing milestone. And in this milestone, we are going to develop an intermediate calculator. It's simply an extension of the previous calculator that we've used in one of our previous challenges or milestones, if I'm not mistaken, where we simply initialized two numbers and printed out the results of some basic mathematical operations that was made upon these two numbers. And now what we want to do is to move one step further. And first of all, I don't want us to initialize these two numbers by ourselves, but rather to give the user for whom we're creating this calculator, right, the ability to enter, to insert his own numbers. So we will simply let the user choose the two numbers he would like to make his calculations on. And also we want the user to specify what mathematical operation he wants to use on these two numbers. Is that okay so far? So your task, your challenge is to write a program that simulates a calculator by getting a character from the user, for example, plus, minus, multiplication, and so on, and also to get two numbers. And the program should simply print the result of applying a mathematical operation on these given two numbers. So for example, if the user specifies a plus character and two numbers 5 and 7, then the result of 12 would be printed on the screen. If the user specified a multiplication character and two numbers, let's say 3 and 5, then the result of 3 multiplied by 5 would be printed on the screen, which in this case it would be just 15. And although you can handle this exercise by just using the if-else structure, you are asked to develop this calculator by using the switch cases because why do you think we need here to use switch cases? If you don't really know the answer to this question, please refer to the previous video where we discussed the switch cases exercises and the reasons and when we would like to use switch cases over the standard if-else structure. So good luck guys, try it on your own, practice the material, and once you're done, check out the demonstration with me for this full explanation of this milestone and how you should solve it. Oh, and make sure to check the correctness when using division operations, because you actually cannot divide by 0 if the user gave you the second number of 0, right, and you want to divide num1 over num2, then you should print a corresponding message that this operation is not legit, it's not possible, all right? So take care of this moment too. And I'll see you in the solutions video. Bye guys. So let's create our amazing intermediate calculator. So for that we are going to create two variables. The first one is num1 and the second one is num2. And also we are going to create a variable, to declare a variable of character type that will hold the mathematical operation sign that we are going to use upon these two numbers, num1 and num2. So let's call it math operation. And now we are going to print a nice message to the user. So printf, enter what math operation you would like to use. So now the user will specify if it's either plus, minus, and so on, plus, minus, and so on, right? We have a couple of options, 5 options if I'm not mistaken. And now we are going to use the scanf function and read the result using the %c, because we are using a character, and we are going to write the result inside of math operation variable, which is of type char. And now we are going also to read the two numbers from the user. So printf, enter num1. We are going to read its values. So scanf %d inside of num1. And we are going to do the same also for num2. So printf, enter num2, and read the value for num2, %d, and num2. So at this point we have the two numbers and the mathematical operation that we want to apply between these two numbers. So now we should use, one option was to use the if-else structure, but we are going to use the switch case. So switch, and after the switch inside of these parentheses, we specify the variable that we want to see what cases can it hold, what cases can it satisfy. So we just use the math operation variable here, and then we are going to open up these curly brackets, and now we are going to specify the cases that this math operation variable can hold. So case number 1 is that this math operation holds a plus sign. And if that's the case, what we are going to do, guys, we are going to print out the result of this math operation. So we are going to use %d, %c, %d, and %d equals to %d. And now I'll explain. So instead of the first %d, we are just going to specify num1. And instead of the %c, we are going to specify the math operation, num2 instead of the third one. So this part simply specifies what operation we are doing. So here will be num1, the math operation, and num2. And then we are also going to have the result in here. So the result in this case is just num1 plus num2. That's it. So just let's add also the break line. Hope you remember this one. So the break line, and also we are going to move this guy a little bit. And that's it for the case of the plus sign. And also we are going to do the same for the minus sign. So minus. And we are going to specify the similar commands. So let's just copy and paste this one and put it in here. So the only thing that is going to be changed here is just here, instead of using the plus mathematical operation, we are going to use the minus. That's it. That's the whole difference. Also, we can do the same for multiplication sign. So we are going to do something like this, and to get it back, here change it to multiplication, and here also. And there you go, you are done with another case. Now what we are also interested in is to check out what will happen for the division operation. So if we have another case where we specify the division between two numbers, then we are going to add another if statement. And we are going to ask if num2 equals to 0, then in this case we are going to print that you cannot divide by 0, all right, which is a good message that will help our program not to crash. And else, if num2 does not equal to 0, meaning we're okay, we can do the division operation, we are going to use the similar printf command that we've used previously in the previous cases. So just copy and paste, and instead of multiplication, we are going to use division. So I hope you got the idea, and similarly we can do also for the last mathematical operation, which is to find out the remainder. So you just remove it, and here instead of this division we use this one, and basically there you go. We just need to also to add the default section, the default section, and if that's the case, if the user didn't specify any one of these mathematical operations, then the default would be just to print him that I don't know, something like that, wrong mathematical operation, try again. All right, \n at the end to get one line down, and a semicolon. Let's just use it for as a default. All right, the break. So I think we are good. Let's just reduce it a little bit and see the whole structure of it. So we've created a couple of cases that check out if the value of the math operation variable, and based on the result of this math operation, we are going to print a corresponding message, just like a real calculator. You specify the numbers you want to calculate and the mathematical operation, and the calculator give you your results. So let's try to build and run it and see what happens. First of all, we are going to increase this console application window, and all right, enter what math operation you would like to use. Let's say we would like to use the plus. All right, plus. Enter num1, so 5, and num2 is 7, and if we press enter, we hope to see that the result is just 12. So 5 plus 7 equals 12, and that's exactly what we expected to see. So this is it for this milestone, guys, and you see the progress that you've made so far, how much you improved, right? I think that you can feel it, that the improvement is being very, very good on your side, and you can also extend this calculator even one step further. That's why we use the switch cases structure, because now if we want to add another mathematical operation, we just can use another case, add here another case, another mathematical operation, I don't know, maybe something like that, like this one, all right? And then we specify the commands and the mathematical operation that should be done and what message should be printed on the screen in such a case. So thank you guys for watching. Thank you guys for trying to do your best, and I'll see you in the next video, which is probably going to be in the next section.